Hello guys, in today's lesson on calculation and chemistry, we're going to continue the lesson we started on the law of chemical combination. In our previous lessons, we discussed the law of conservation of mass, and after that we went on to the law of constant composition or definite proportion. And today we're going to be discussing the law of multiple proportion. And also in our previous lessons, we discussed how various scientists such as Mikhail Lomonosov, Antonin Lavoisier, James Louis Proust, how the scientists explained the various ways chemical substances combine together from a qualitative standpoint, or that is from a qualitative angle, until when John Dalton, the scientist we're going to be discussing today, came into the scene to summarize all the works this great scientist, discussed, by looking at how chemicals combine together from a quantitative standpoint. Now, at the age of 37 in 1803, John Dalton put out what they call the Dalton's atomic theory by stating out a couple of things he observed, based on how atoms of various elements combine together. Dalton's work paved the way for more work on stoichiometry. Now, when we talk about stoichiometry, we're talking about a branch of chemistry that deals with the measurement of various reacting chemicals and the product they form. And also, periodic table was invented, thanks to Dalton's work being a basis, for this. Great scientists like Dmitry Mendeleev and even Henry Moseley were able to use Dalton's work to bring about the invention of periodic table. Now, Dalton stated out a couple of things in his book, Dalton Atomic Theory in 1803 at the age of 37. He said something. The first thing he said was, every element is made up of, atoms. For example, chlorine has its own atom known as chlorine atom, sodium has its own atom known as sodium atom, and so on and so forth. That's the first thing they said. The next thing they said was that every atom, since every element has their own atoms, these atoms are also made up of masses. That is, they have a given mass or they have a given weight. That's the next thing they said. And the next thing they said was that when a given element reacts with another element, their atoms come together. Their atoms are what combine together, are what react. And when these atoms react, it does not bring about a transfer of these atoms. That is when chlorine and let's say chlorine and sodium react, for example. After reaction, if you check the sodium element, you will not find chlorine atom in the sodium element. And if you check chlorine, you will not find sodium atom. That is sodium donates some atoms, chlorine donates some atoms, and they bond together. And this was these were Dalton's discoveries, in 1803. And after that, he went on to put out this very law we're about to discuss, known as the law of multiple proportion. Now let's see what Dalton said about this very law. Now, according to John Dalton in 1803, Dalton stated that when the multiple masses of an atom of an element combine with the fixed mass of an atom of another element to form multiple compounds. They do this in a simple whole number ratio. Now, this is Dalton's law of multiple proportion. Now, according to John Dalton, after all the works he carried out, he was able to come to the conclusion from his observation that provided we have an atom of an element, let me say elements like copper, elements like carbon, and this major element, the other kind of element also, even lead. And when we look at this very element with multiple, oxidation numbers, when you look at this very element, each time this very element combined with another element with a fixed oxidation number, that is fixed mass, that observe that each time we have this kind of combination, they combine, this combination happens in a simple whole number ratio format. That's according to John Dalton. Now, Dalton did a very wonderful job by opening the eyes of scientists to the quantitative world of, of stoichiometry, of chemical measurement. Unlike before Dalton came, other scientists were merely concerned about qualitative part, or, qualitative analysis of these chemicals. Until Dalton came to the scene, then he was able to summarize all the great works of people like Luminoso, people like Antoine Liversa, people like James Louis Proust, and even Benjamin Richard. We're going to be looking at his work in the next lesson, the work he did on the law of reciprocal proportion. That'll be our final law on chemical combination. So according to John Dalton, this is what they said. They said each time the various masses of a given element combine with the fixed mass of another element, during this combination, they do so in a simple whole number ratio. They do so in a ratio format. But what kind of ratio format is this? In a simple whole number ratio format. So we're going to be looking at a couple of calculations that will help buttress the point, that is point on this.